Area of composite figures. So composite figure is not a simple figure. It's something like if we have a rectangle uh, with multiple triangles coming out of the sides of the triangle or out of the sides of the rectangle, or even I'm trying to make a semicircle. This would be an example of a composite figure where we have multiple pieces to this going on at the same time. So to calculate area, there are two main strategies. You can split a diagram into smaller pieces and add those up, and that's the split and add technique. The other technique is to identify a larger figure, a bounding figure, calculate that area, and then subtract the negative space. So this one, I don't see anything bigger that it's easier to do than to split it into smaller shapes. So I notice we have these two together are going to make a circle, and then we have a rectangle in the middle. So we'll want to find the area of each shape. So we'll find the area of the circle and find the area of the rectangle. In the circle, we have pi r squared, and r is 10, so we can do pi times 10 squared, which will be 100 pi square feet. And then for this, we need to find the height. Because that's the radius, we can say that this is also 10, that's also 10. So overall, the height of this rectangle is 20. So we can say that for the rectangle, we have base times height, which is 20 times 30, or 600 square feet. If we're rounding, then we would get 100 pi plus 600 is going to be about 914 square feet. So I just found the two areas, added them up. For this one, let's try doing the exact same thing. Let's look at the triangle separately from the rectangle. So this is going to be 7.2. By subtracting from the 15, this will be 7.8. This is 12. And then by subtracting from the 18, this will have to be 6. So the triangle on the left is 1/2 base times height. The base is 6, and the height is 7.2. The triangle on the right is also 1/2 base times height. The height is 7.2, and the base is 12. And lastly, the rectangle. The height is base times height. The height is 7.8, and the base is 18. Now we've set it up, we can simplify each of these. The first one simplifies to 21.6. The second one simplifies to 43.2. And then the last one simplifies to 140.4. So to find the total area, the total shaded area, we're going to want to add all of these together. So when we add them all together, we're getting 205.2. And then we want to make sure we use the units, square millimeters. But we could also do this by looking at the larger shape. If you look at the larger shape going on here, you can say that that's a rectangle, and then subtract out the negative space of the triangle inside. So the rectangle, the whole thing, is a base of 18 and a height of 15. So base times height is 18 times 15, 18 times 15 is 270. For the triangle is 1/2 base times height. 1/2, the height is 7.2 and the base is also 18. So 18 times 7.2 times 1/2 is 64.8. And what we want to do now is not add these, but subtract them, because this was the whole. We want to subtract that, and we'll get the same thing we got before, 205.2 square millimeters. Let's try a few more. Here, this shape could be split into smaller pieces, but I actually think it will be easier if we look at the large, if we put a large rectangle around it and then subtract out pieces. So I'm going to subtract out a square, a triangle there, a triangle there, and then a triangle at the bottom. So the whole thing goes from -3 to 4, so that's a 7. Up to down is also 7, so 7 times 7 is 49. The triangle on top is 1/2 base times height, 1/2 5 times 2. The green square, you can just count the boxes or do 2 times 2 to get 4. This is 2 by 5, so 1/2 times 2 times 5 once again gives us 5. And then the purple was 1/2 times 1 times 7. The height is 1, the base is 7. And that's going to give us 3.5. So overall, we have 49, and we want to subtract 5, 4, 5, and 3.5. So this is 5, 4, 5, and 3.5, representing the 4 different shapes that we're subtracting out. So if you add up these pieces, this is the same thing as subtracting 17.5. And then 49 minus 17.5 is 31.5. So that's our area of the quadrilateral inside. This was not one of our listed quadrilaterals. There's no special name for this. So this is definitely the best way to find. This diagram, we have missing information. We need to find that side in order to find the area of the whole figure. So this is the radius. It's also the adjacent side, and 3 is the opposite side in this triangle. So we can say that by tangent, if you've forgotten trig, you want to go back and look at your trig again. Tangent says 3 over x. So when we solve that, we get that x is going to be approximately 0.368 feet. And using that, we can look at the area of the semicircle and the area of the triangle. So for the triangle, we're going to do 1/2 base times height. Now the base is going to be x times 2, so it'll be 2 times that 0.368. Because this was 0.368, so this will also be 0.368. And the height was 3. So that gives us an area of 1.105 square feet. For the area of the circle, sorry, not circle, semicircle, the whole thing would be pi r squared, but since we're looking at half of it, we'll do pi r squared divided by 2. So this is going to be pi times 0.368 squared over 2. Multiplying that out and dividing by 2 gives me about 0.213. So the total area is adding up that 1.105 and 0.213 together to get 1.138, and we should say square feet. Lastly, here we have a rectangle. Is the whole thing 8 times 9 gives a total area of 72 square centimeters. For this, we have a bunch of 2 by 2 boxes. So I can tell that that 2 is the same as this 2, and that 2 is the same as this 2. So we have, this is 2 by 2, this is 2 by 2, this is 2 by 2, for a total of 12 square centimeters. So the negative space inside is 12 square centimeters. When we subtract that out, we get 60 square centimeters. So that is how we can calculate areas of more complex figures, splitting them into smaller shapes and adding them up, or bounding them and subtracting them.